Let's look at solving equations using reciprocals. So using reciprocals to solve equations. So we're going to follow the same rules, and we're going to undo what's happening in our variable, do the same thing to both sides, and only one equals per line. So let's use reciprocals to solve equations. So first of all, let's look at an equation that has a reciprocal that we can use a reciprocal to solve. So let's say we have 3/5 x is equal to 20, let's just say. So that might be 3/5 of a pizza costs $20. How much does a whole pizza cost? So we can solve that kind of problem. So 3/5 x equals 20. Solving one-step problems using reciprocals. Well, multiplying by a number has an inverse, and the inverse of multiplying by a number is either dividing by that same number or multiplying by its reciprocal. So we're going to do multiplying by its reciprocal because this has a coefficient that is a fraction. So since the coefficient is a fraction, one of the ways to take care of it is to multiply both sides by the reciprocal of that fraction. So let's take a look at doing that. Well, the reciprocal of 3/5 is 5/3. So I'm going to multiply the left side by 5/3 and the right side by 5/3. This undoes that, this undoes that, leaves me with just x equals, well, 20 times 5/3, that's like 20 over 1 times 5/3. That doesn't simplify at all, and so we get 100 thirds. So x equals 100 thirds. We started with 3/5 x equals 20, and all we did was we multiplied by the reciprocal to get rid of that. Let's take a look at another problem. How about 12 equals 6/7 q. 12 equals 6/7 q. So we need to get rid of that 6/7. So I'm going to multiply by the reciprocal of 6/7. Now I'm going to change color to red just so you can see, because we kind of need to squeeze it in there, because if I multiply it over here, oops, that's not even the reciprocal. If I multiplied it over here, it would just kind of be too far away for me to really see what's going on. So I want to squeeze it in here, but I want to make sure not to lose it. So I'm going to multiply it by its reciprocal. And if I multiply by the reciprocal over there, I have to do the same thing to both sides. And now this goes poof, this goes poof, and we're left with just q over here. And then 7/6 times 12 over 1. Well, that can be simplified. And so we get 14. Let's take a look at another problem. But they're all really pretty much the same. So let's say we have 15 equals 1 2/3 x. Well, the first thing we need to do is make improper fractions. You've heard me say it before that we deal with improper fractions here in algebra. So 15 equals 5/3 x. That's just making that 1 2/3 into an improper fraction. And now I need to multiply by the reciprocal, because remember, multiplying by the reciprocal is the inverse of multiplying by the number. I'm going to squeeze it in here, and again, I need to multiply by the reciprocal. Make sure you multiply by the reciprocal. You saw I almost made a mistake there. And so then this simplifies. 3 times 3 is 9, and this goes poof, poof. We're left with just x. So in this case, x equals 9. And the really cool thing is I don't know many people that would be able to tell you right off the bat that x equals 9 if they were given 15 equals 1 2/3 x. And that works out really nice. And that's it for using reciprocals to solve equations.